Hello and welcome to aTech. Today we're exploring the story of a country already immensely wealthy thanks to oil, Norway, which seems to have discovered a resource that may even be more strategic. In the agricultural region of Rogaland, geologists have identified a concentration of phosphate rock on an unprecedented scale. Could this deposit outweigh black gold in the global economy? Can Norway become a key player in food security and the energy transition, all thanks to phosphate? And is this potential windfall a sustainable blessing or an environmental time bomb? To understand the stakes, let's briefly go back to Norway's oil history. In 1969, the discovery of the Ekofisk field in the North Sea changed the country's destiny, transforming it from a fishing economy into one of the most influential hydrocarbon producers. Black gold, managed prudently, has reached approximately 1.7 trillion in assets by 2025 and remains the world's largest sovereign wealth fund. This forward-thinking management has allowed the country to prepare for the post-fossil fuel era while still remaining a major exporter of oil and gas. Following Russia's large-scale invasion of Ukraine, energy prices soared and revenues from Norwegian hydrocarbons reached record levels in 2022, further strengthening this fund. In parallel, Norway is already moving toward a rapid energy transition. It's taxed carbon since the 1990s and has begun electrifying some of its offshore platforms to reduce emissions associated with oil production. But it's in the transportation that the change is most spectacular. By 2025, approximately 96% of new cars in the country are battery electric vehicles, a world record that practically puts an end to the new combustion engine cars in the Norwegian market. This shift is facilitated by electricity that's over 90% hydropower, giving Norway one of the most decarbonized electricity mixes in the world. The discovery of a strategic mineral now offers it the opportunity to complete this paradox, remaining an energy giant, but this time at the heart of the transition rather than fossil fuels. It's in this context that the word phosphate comes forward. It's estimated that around 80 to 90% of the phosphate extracted worldwide is used to make phosphate fertilizers, one of the three major nutrients along with nitrogen and potassium needed to maintain soil productivity and feed a global population of over 8 billion people. Without this input, agricultural yields would collapse in many regions. Today, phosphate has a dual strategic value. It remains essential for global food security, but it's also become a key in the energy transition, particularly through lithium iron phosphate (LFP) batteries. These batteries, increasingly used in electric vehicles and renewable energy storage systems, are valued for their good lifespan, thermal stability, and lower dependence on certain rarer or more expensive metals like cobalt and nickel. Phosphate is also involved in certain processes related to solar panels and advanced electronics, further enhancing its strategic dimension. The problem lies in the very uneven distribution of this resource. Morocco and Western Sahara alone concentrate about 50 billion tons of reserves, making it by far the world's leading phosphate power. China, Egypt, Tunisia, and Russia also have significant reserves, but Europe is highly dependent on imports for its fertilizers and part of its industries. This vulnerability was highlighted when China began limiting its exports of certain phosphate products from 2021 onwards to secure its domestic market and its own food security. The European Union reacted by officially recognizing the strategic threat that a supply chain disruption would pose to agriculture and industry. It's in this strategic void that Norway, through the Anglo-Norwegian company Norge Mining, enters the scene. In Rogaland, the company announces it's identified a colossal deposit of phosphate rock associated with remarkable concentrations of vanadium and titanium. Published estimates indicate a potential of at least 70 billion tons of phosphate rock. This compares to known global reserves in the early 2020s, which stood at around 70 to 75 billion tons according to several analyses. If these figures are confirmed and the deposit is exploitable, Norway could nearly double accessible world reserves. This deposit could help cover a significant portion of the global demand for phosphorus for fertilizers, LFP batteries, and certain energy transition technologies for several decades. In this matter, Europe sees an opportunity to reduce its dependency on more politically sensitive suppliers. Furthermore, the same deposits contain vanadium and titanium, two critical metals for aeronautics, defense, certain types of stationary batteries, and many high-performance alloys. Today, these metals are mostly produced by BRICS countries like China, Russia, Brazil, or South Africa. This reinforces the interest in having an alternate source in a politically stable country. The emergence of an ally like Norway in this role is thus perceived as a major asset for the security of Western supply chains. However, geology is only the beginning of the story. Extracting phosphates on a large scale is technically complex and raises major environmental challenges. The production of phosphoric acid, the basis of most phosphate fertilizers, generates enormous quantities of residues called phosphogypsum. This waste can contain traces of natural radioactive elements such as radium and uranium, as well as heavy metals. For each ton of phosphoric acid produced, several tons of this residue accumulate, forming gypsum stacks that can reach considerable heights. The example of Florida illustrates the risks well. In recent decades, phosphogypsum stacks have experienced collapses or leaks of contaminated water. U.S. authorities consider these deposits too radioactive to simply be buried. This forces them to be left on the surface under costly long-term surveillance. Norway, which cultivates an image as a green champion with ambitious climate goals, cannot afford to be associated with hills of toxic waste on its territory. It's already developing CO2 capture and storage projects in the North Sea fields and relying on its largely decarbonized electricity to limit the carbon footprint of its new industries. In this context, Norge Mining and the Norwegian authorities are promoting the idea of responsible extraction based on the intensive use of hydropower and, ultimately, on advanced processing technologies to reduce waste volumes and recover value from the gypsum produced as much as possible. The stated goal is clearly to distinguish themselves from the most polluting practices observed elsewhere by integrating climate and radiation protection constraints from the outset. Symbolically, this deposit is already at the heart of two vital issues: food security via fertilizers and the energy transition via batteries and certain low-carbon technologies. Economically, success will depend on the speed, profitability, and responsibility of production. The spectacular figures for reserves and potential value imply extraction over several decades, but mining realities are slow. Norge Mining talks about a timeline of several years, perhaps up to a decade, before significant industrial production, allowing time for impact studies, obtaining permits, and building infrastructure. Norway has the advantage of its geology and political stability, but also the obligation to show that it can do better, ecologically and politically, than the traditional extractive model. This new chapter is therefore a real-world test for Norway. If it succeeds in exploiting this treasure of phosphate, vanadium, and titanium while respecting its climate and environmental commitments, it could become a key supplier for the global energy transition while strengthening the food and industrial security of Europe and other regions. But if the management of this resource runs into conflicts of interest or poorly controlled environmental problems, Norway will discover that some mineral riches are almost as difficult to manage cleanly as an oil well in the middle of a storm. As always with natural resources, the real question is not just what we have beneath our feet, but what we collectively decide to do with it. That concludes this analysis. Thank you for following along to the end. If you enjoyed the video, feel free to leave a like and tell us your opinion on this situation in the comments. New episodes are coming soon, so don't forget to subscribe to the channel and hit the bell to never miss a thing. I'll see you soon.